Welcome students. Today we are going to learn about Vedic subtraction. So now introduction to Vedic subtraction method. Now what are we going to learn today? We are going to learn by 6 parts. The first part is subtraction method, all from 9 and the last from 10 method. The second method is the concept of base. The third method is adding zero method. And the fourth one is subtracting near a base. Now in fifth part, we will learn some problem with money. And at last, we will learn subtracting number just below the base. Now, we know addition is also one of the most basic operations subtraction is also one of the most basic operations like addition. And for subtraction, there is also some Vedic sutras. One of the famous sutra mentioned in Vedas was Nikilam Navutaskaram Dasta. That means it is very important formula for subtraction from the numbers like 10, 100, 1000 or the numbers made with 0 and 1. Now, here in the method, basically all the digits before the last digit is subtracted from 9 and the last digit is subtracted from 10. We will use the method to generate some basic results and formula. Now, let me take an example of it. Let me take a simple example, 100 minus 57. Now, what is our method? All from 9, but the last from 10. So, there is 2 digits in 57. Okay. So, we need to subtract 5 from 9 and 7 from 10. Yes. Then what will be the result? The result, the first digit will be 9 minus 5. I am writing it explicitly to understand it better. The first digit will be 9 minus 5, that is 4. And the second digit will be 10 minus 7, that is 3. So we are doing in this way that except the ones place, we are subtracting all the digits from 9 and we are basically subtracting the digit at one place from 10. So let me take another example for 1000 minus 345. So what will be the method? Yes. We need to subtract 3 from 9, 4 from 9 and 5 from 10. So the digit at the hundreds place will be 9 minus 3. That is 6. Digit at tens place will be 9 minus 4. So that will be 5 simply. And the final digit will be 10 minus 5. Remember, we need to subtract the final digit from 10, not from 9. This is the formula. So the result will be 1000 minus 345 is 655. As simple as that. Now, in this method, there are some advantages as well as some disadvantages also. The advantage of the method is, in this method, we don't need to check what from what we are subtracting. Say, if we are subtracting from 1000, if we are subtracting from 100, we don't need to go or we don't need to do anything with 100 and 1000. We are just checking the number, the second number, and what we are doing, we are breaking the second number, we are taking all numbers except the one digit and subtracting all those numbers from 9, and we are subtracting the number at 10 one digit from 10. So in this method, we don't need to check for 100,000, 10,000, etc. But there is a big problem with it, that without the 100,000, 10,000 and the numbers like that, the method may not work in properly. Say, if we just take 999 instead of 1000, so what will be your answer? That will be 654. In this method also, check the digit at hundreds place is subtracted from 9, then it will give us 6. The middle digit subtracted from 9 gives us 5, but the last digit is not subtracted from 10. It is also subtracted from 9. So we can't do the previous mentioned method in such cases. So remember that thing. Now we will introduce another term that is very useful for Vedic mathematics, is base. The numbers made up of only zeros and ones are known as a base. So let me take some example, say 10, 100, 1000, 0.01, 1, etc. are called base. Now, what is a base method? In base method, the base method is very useful for subtracting, multiplying, and dividing a number basically. But for this, we will define numbers near the base as close. That means 98, 99 are close to 100, 9 is close to 10, etc. So basically, we are doing like we have done in addition. Say, if we can remember, in addition, we have done the completion method. So in this also, we are basically taking the numbers to their nearest base. Okay. So what is the profit of taking a number to its nearest base? Let me check. Applying the formula all from 9 and last from 10 to any number, especially the big ones, reduce it to its smaller counterpart that can be easily used for calculation involving the big digits. Here, big digits mean 7, 8, and 9. Applying the formula all from 9 and the last from 10. Okay. Let me take another simple example of subtracting from a base. So, 1000 minus 876. Now, what will be the answer? For 876, and the nearest base is 1000. Now, we don't need to check anything because here the first number is 1000, so we can go with the previously mentioned method. Okay. So what will be the method? All from 9 and the last from 10. So let me introduce again that we need to subtract every digit except the ones place digit from 9, and the ones place digit will be subtracted from 10. So what is the first digit here? 8. So 8 subtracted from 9 will give us 1. Then 7. 7 subtracted from 9 will give us 2. And finally, it is 6. It is subtracted from 10. Remember, the last digit will be subtracted from 10, not from 9. The last digit will be subtracted from 10. So, the last digit minus 6 is 4. We know that. Now, from the all from 9 and last from 10, 9 minus 8 is 1, 9 minus 7 is 2, and 10 minus 6 is 4. So, if we just introduce the concept of base, the numbers like 10, 100, 10,000, 1 lakh, 0.01, we take another example. Here, I am taking an example that is 400 minus 57. So, we know that 400 is 4 into 100. Yes. So 400 is a multiple of a base. Yeah, we know that. So we have 400 instead of 100, as we have mentioned in the previous example, that was 100 minus 57. So here I am not taking the base, but I am taking a multiple of base. Remember, here we are not directly taking a base, we are taking a multiple of base. Now, for multiple of base, we first reduce the first 4, the first digit. The first digit here is 4. So we will reduce the 4 to 3 by 1. So reducing the first digit to its previous digit is called 1 less than 1 before. Okay. So in this method, what we need to do? We need to reduce the first digit with this method, and we will reduce the first digit to its previous digit, and the all from 9 and last from 10 is applied to 57 to give us 43. We know that, because say if we assume it as 100, then it will give us 100 minus 57, 43 in this way. But if we assume it as 100, I am repeatedly saying if we assume it by 100, we need to reduce the 4 to 3, because 57 will come from one of those 400. So that 300. So if we consider 400 as 300 plus 100, for our better understanding, we are considering 400 as 300 plus 100. Then also 100 minus 57 is 43, and the 300 is laterally added. But in this method, we don't need to add it laterally. We just adding the method using the method of all from 9 and the last from 10. Okay. Now, let me come to another method. This method is adding zeros. In all of the above sums, you may have noticed that the number of zeros in the first number is same as the number of digits in the number being subtracted. Okay. So let me go to the previous example. Okay. What was that? 400 minus 57. So how many zeros the number 400 have? Yes, 2. And how many digits the number 57 have? Yes, 2. And if we just go previously, how many digits the number 1000 have? 4. And how many zeros the number 1000 have? 3. And how many digits the number 876 have? Yes, 3. Now we may have noticed that the number of zeros in the first number is the same as the number of digits in the number being subtracted. Now we will consider the non-similar case. That means where the number of zeros is not equal to the number of digits which is being subtracted. For example, 1000 minus 81. So here, how many digits 1000 have? 4. How many zeros 1000 have? 3. And how many digits 81 has? 2. So 1000 has 3 zeros and 81 has 2 digits. But to make a good subtraction method, or to apply the formula that all from 9 and the last from 10, we need to basically convert the 81 to a 3-digit integer. So how can we convert a 2-digit integer to 3-digit integer? We can't add 0 in the middle, because if we add 0 in the middle, it will be 801. We can't add 0 at last because it will be 810. So we only have one option, that is adding 0 in front of 81, because 081 is equal to 81, and if we add even more number of zeros in left side, that won't change our result. Yes. So for better calculation, we are taking here a 0, extra 0 before the 81. And now it is very easy. 1000 is a base number. So apply the previous method, 9 and last from 10. So 0 will be subtracted from 9 to give us 9. 8 will be subtracted from 9 to give us 1. And 1 will be subtracted from 10 to give us 9. Okay. Another example. Here we are finding 7000 minus 4432. Explanation of the method. One more than the previous one, and all from 9 and the last from 10. Considering the 1007 will be reduced by 5, that is 1 more than 4, because we are taking more than 4000. So it is a multiple of base. Okay, consider it for better understanding as this is basically 7 units of 1000. Say consider 1000 as an unit. Okay. So just I am taking a childish example that if we want to measure a 7 centimeter from a scale, what we can do? We first put a point at 1, and then we are calculating the number which is 1 plus 7, right? So here consider the 1 semi. Here we consider 1 semi as a unit. And for this example, let me consider 1000 as an unit. Okay. So if we consider 1000 as a unit, 7000 will be 7 units. So from a 7 units, we are subtracting a number which is more than 4 units. Okay, so understand slowly, but try to understand the meaning of the problem. So 7000 means 7 units and 4432. That means a number which is more than 4 units. So if we take more than 4 units from 7 units, what will be the remaining? The remaining will be a number which is less than 3 units, because we don't know the exact number, because we will subtract and get the exact number. But we know the number we are subtracting has a value from 4 which is greater than 4 unit and less than 5 unit. Yes. So the number will be greater than 2 unit but less than 3 unit. Okay. So we know that when we are crossing the 4000, that means when we are taking even one more than the 4000, say 4001 or 4002, or here in this case 4432, the number 7 will become to 5. Why? Because we are taking more than 4000. Again, I am saying when we are taking more than 4 units, that will result a number which is surely less than 3 units. So for surely less than 3 units and surely greater than 2 units, we know the first digit will be 2. Yes. And 4 will be considered as 5. So the first number will be 2. And letter is very simple. We will just take the previously mentioned all from 9 and the last from 10 method with the last 3 digits of 4432. That means 1000 minus 432. Yes. Why 1000 minus 432? Because it is a 4-digit subtraction and we know that here the carry will be 1. So it will be basically give us 568. So the first digit will be 2 because we are taking away a bit more than 4 units. So the first digit will be 2 because we are left with a certain number which is more than 2 unit and less than 3. So the first digit will be remain as 2. And later we will use the previously mentioned all from 9 and the last from 10 method to get the final result. Similarly, 8000 minus 3102. So in this method also consider 8000 at 8 units. Okay, 1000 as 1 unit and 8000 as 8 units. 3000 as 3 units. So 3112 means a number which is a bit greater than 3 units. So when we are subtracting a number greater than 3 units, that will result a number which is greater than 4 units but less than 5 units. So what will be the first digit? The first digit will be 4 because it is greater than 4 units. I am repeatedly saying we need to check from the period of the first number. So the first number we know that greater than 4 units, so the first digit will be 4, and for the latter part we will use the previously mentioned formula. Okay. Now we are coming to another formula, that is subtracting near a base. What the formula is saying? The rule here is by completion or non-completion. As we have mentioned the completion or non-completion method in addition video. The method is very similar to the addition. When we will subtract a number close to a multiple of 10, we will just subtract from the multiple of 10 and correct the answer accordingly by adding the extra part. Okay. So let me understand. 64 minus 38 equal to 26. Here we know that 38 is close to a multiple of base. Here the base is 10 and the multiple of base is 4 into 10, that is 40. So we will first subtract 40 from 64. So what we are subtracting? We are directly subtracting the nearest multiple of the base. Yes. So here the nearest multiple of the base of 38 will be 40. So we will first subtract 40 from 64. Then we need to add 40 minus 38, that is 2, with it to get the final result. Okay. So this method is very easy when we are taking even the 3-digit subtraction also. Let me show another example to you. Okay. So we are taking the example, say 1600 minus 657. Okay. So for 657, what is the nearest multiple of base? Yes, it will be 660. Because 660 is 66 into 10. So the base is 10 and we are taking the multiple 66 into 10. Okay. So you may take the base as your choice also, but here I am taking the base 10 to make the calculation very easy. So if we take 660 from 1600, then how much we need to add later? We just need to add a 3. So what will be the result? What will be the result? 1600 minus 660. So the result will be 940 plus 3. Yes, 940 plus 3. How we can do that? How we can do the 1600 minus 660? We know that we are taking away, let's say here we are considering 100 as unit, so 1600 is 16 unit, and we are taking a number which is bigger than 6 unit but lesser than 7 unit. So the first number will be 16 minus 7, so 9, and the latter part will be followed by all subtracting all from 9 and the last from 10 method. Okay. So in this case, the inner subtraction you can do by your method, any method. But subtracting near the base, you need to consider the number which are being subtracted as the summation or as a combination of two numbers. One of them will be multiple of base and one of them will be a single digit. So let me take another example. Say 19,000 minus 345. What can be done in this situation? So in this situation, we will consider the nearest base of, the nearest multiple of base of 3,456. Okay. So 19,000 minus 3,460. That will be very easier. And here we will add 4. So the method will be 15,500 before, yes, 15,540. Yeah. So this method is very easy. Now, problem with money. We know that in Vedic era there was some different amounts and different measurement of money. But remember one thing, that the usual method which we are using in modern era with the economy or with the banking system, the problem related to money, the root was discovered in Vedic era. So first we know that when we are doing a problem with money, the first basic result is 100 paisa is equal to 1 rupees. Okay, so here we will just use the basic result, and we will adjoin the basic result with a Vedic method of subtraction. Let me adjoin these two methods. We can use the all from 9 and the last from 10, again the method, to find the difference between money amount also. For example, what change would you expect from rupees 3000 when paying rupees 4.86? Okay, so let me discuss the example. So we have 30. Yes, we have 30 rupees and we need to pay 4.86. So first, to use the all from 9 method, we need to do 30 as 30.00. Okay, so after decimal, we can put 0. So 30.00 is 30, nothing else, and 4.86. Now, what will happen in this case? In this case, we are rewriting the problem in such a way that the first number, that is 30 rupees, is acting as a multiple of base. Okay, so let me just take the example without the decimal. What will be the example without decimal? That will be 3000 minus 486. So what is 3000? 3000 is a multiple of base. And what is 486? 486 is a number which is close to 490. Okay, so we know that if we have the similar number of digits after the decimal, we can just do without the decimal, and then we need to put the decimal after counting the number of digits. Okay, so here we will consider the calculation without the decimal. So what will be the calculation without the decimal? I am just writing without the decimal, but don't write it without the decimal in when you are doing it in exam or for say final calculation. So I am just for better understanding here I am writing the method without the decimal. It will be 3000 minus 486. So the method will follow as the previous method. So what will happen? Here 3 will be reduced to 2. We know that the first digit is reduced by 1. Yes. And then for 86, it will just follow the previously mentioned all from 9 and the last from 10. So 1000 minus 486 it will happen. So for 4, it will be 9 minus 4. So 9 minus 4 will be 5. Then 9 minus 8 will be 1. And finally 10 minus 6 it will be 4. So 2514. But we had the decimal. We had the decimal from 2 digits from the last. So we need to put it from 2 digits from the last. Here we are basically, when we are taking 3000 from 30, we are basically considering the paisa, or from rupees we are converting to the paisa. Okay. So the rupees left is 25 rupees and 14 paisa. Okay. Again, you can do this as also the multiple of base system, that is the change you expect to get is rupees 25.14 because rupees 4.86 subtracted from 10 is rupees 5.14. So basically what we are doing here, okay, what we are doing here, we are basically doing 30 minus 4.86 as 30 we are breaking 30 as 20 plus 10 minus 4.86. So it will be also an easier method because we know that 10 minus 4.86 will just follow a multiple, a subtraction from general base. So we don't need to reduce 3 to 2, or we don't need to reduce the first digit. We will just follow the method that is all from 9 and the last from 10. Because we know that if we just carry it without the decimal, it will be like this: 2000 plus 1000 minus 486. So the latter part without 2000 will be 1000 minus 486. So 1000 minus 486 will just follow the method of subtraction from base and give us 514. Okay. So it is a bit easier way. And remember one thing: don't forget to mention the decimal place. And when we are taking away the decimal place, write it as that we are taking the decimal place, or we are multiplying the decimal place by 100, or something which don't affect your calculation. So here we can put all the decimals. You can also put it after the calculation. Now, with the usual method, we will just introduce two new methods. That is number splitting method. As we have mentioned in the addition, in Vedic mathematics, the addition was done in this way, that when we were adding the numbers, if you can remember the process in the previous video, I have mentioned that when we were adding the numbers, we actually were splitting or breaking the numbers in two or more parts, and were adding the part by part, and finally taking the parts as the digits. Now, for the subtraction also, we have the scope of splitting method. Now, let me take a 4 cross 4 example, that is 6543 minus 3432. Here we will break 6543 into two parts as 65 and 43. As I have mentioned in the earlier videos also, that don't write that 6543 65 plus 43 or something. We are breaking it. We are not defining any other addition or extra subtraction method or any other algebraic operation on it. We are just breaking it. Okay. So just put an imaginary line. Okay, take an imaginary line or put it from the middle of 6543. It will divide the number as 65 and 43. And what will be for 3432? It will be treated as 34 and 32. Yes. Now, as we have done in the previous video, okay, what we have done in the previous video, we have added the first part with the first part. So here we will subtract the first part of the letter number from the first part of the first number. So what is the first part of the letter number? That is 34, and it will be subtracted from 65. Yes. So 34 from 65 will give us 31. And then 32 is to be subtracted from 43, or the latter part is to be subtracted from the latter part of the first number, that is 43. So 43 minus 32 will give us 11. So the number is 3111. So let me take another example, that is, say, I am just taking a bit simple example, 7689 minus 1234. You can break it in 4 parts also. So if we break 7689 in 4 parts, what will be the part? The parts will be, each part will be a digit, 7, 6, 8, and 9. And if we break 1, 2, 3, 4 in 4 parts, what will be given? The parts will be 1, 2, 3, 4. Now if we just do the usual method of subtraction, what will happen? We will the first digit will be 7 minus 1, that is 6. The second digit will be how much? 6 minus 2, 6. That is 4. The third digit will be, here the third digit of the first number is 8, and the third digit of the second number is 3. So the third digit of the final result will be 8 minus 3, that is 5. Okay. And finally, the last digit will be 9 minus 2, that is 5. Okay. So the result is 64. So we can do by breaking in 4 parts also. In this example, we have shown that thing. Okay. Now we have came to the last part of today's discussion, that is general method of subtraction, that is subtraction from left to right. Okay. So in this method, using the Vedic sutras, we can do subtraction from left to right. We know that subtraction is usually done as usual addition from right to left, but we know that from Vedic, we can do it from left to right also. In this method, we will show a very easy method of subtracting. Here we start from the left, subtract and write down. If the subtraction in the next column can be done, if it can be done, then we will put down 1 less and carry 1, and then subtract in the second column. So let me take another example. So say I am just taking example, that is say 53 minus 29. So write it in column way, 53 minus 29. So what will happen? From left to right method, what will happen? We first need to subtract root from 5. So 2 from 5, we know that it will give us 3. 5 minus 2 will give us 3. But remember, 9 can't be subtracted from 3. Right? So if 9 can't be subtracted from 3, we can't do the left to right method directly. So what we need to do then? We have mentioned that we will reduce the first part or the first digit or the first result by 1. So what will be 5 minus 2? 5 minus 2 is 3. We need to reduce it by 1. We need to reduce it by 1. Reduce it by 1. So it will be 3 minus 1, that is 2. And why we need to reduce it? We need to reduce it because 9 cannot be directly subtracted from 3. As we know that we are considering only positive cases, so I am not going for the negative cases of higher algebra. You may say that, okay, 3 minus 9 will be minus 6, but I am not getting the negative part of the number line. I am just keeping myself on the positive part, or basically greater than or equal to 0 part of the number line. So in this method, we can do from left to right in this way also. So these are all methods of quick subtraction. So thank you for seeing my video, and later part we will know some basic tricks of multiplication, division and applications of them. Thank you.